Welcome to the 4.03 Algebra 2 notes today. And we're going to be talking about inverses. All right, so to find an inverse, what you're doing is you're reflecting over the line y equals x. So each point must be reflected over the line y equals x. And you guys did a lot of reflections last year in geometry. So hopefully you remember that the line y equals x goes through 0, 0, has a positive slope of 1. You can put that in your calculator if you need to see it. And if you were to reflect a point, let's say the point, I don't want that one, 3, 1. Then I would go one diagonal box to get straight to that line, and then I'd go one diagonal box away. So now my new point, originally it was 3, 1. My new point is 1, 3. So what happens is when you reflect over the line y equals x, you just switch your x and y. So the point 2, 5 would become the point 5, 2. So first let's look at this in a table. So given the relation, again, a relation is just a set of ordered pairs. So I'm going to give it to you in the form of a table. And the x values are 2, 3, 7, 9, and the y values are 4, 6, 9, 11. So I want you guys to find the inverse. So when we look at the inverse, we're going to give it back again as a table, but we're going to take all of our values and switch them. So you could do it by point or by each row. So if we look at it by each point, you're going to have 2, 4 is going to become the point 4, 2. Or you could look at it as taking all of these x values and they're going to become your y values. And then all your y values, well, they're going to become your x values. So we'd have 4, 6, 9, 11. And down here we'd have 2, 3, 7, 9. So the point 9, 11 becomes 11, 9. So the x and the y just switch. Also, while we're talking about inverses, it's important to talk about functions and one-to-one functions. So remember, if you tell if something's a function or not, then we use the vertical line test. So if the original function is 1-to-1, then that tells us the inverse is also a function. Well, what does that mean, 1-to-1? Well, a 1-to-1 function, 1-to-1 function passes the horizontal line test. So it's kind of the opposite of our vertical line test of being your function. So we say for a function, each x has exactly one y. For 1-to-1, we say each y has exactly one x. So you shouldn't have any y values repeat. So 1-to-1 passes the horizontal line test. If the original function is 1-to-1, then the inverse is also a function. Well, hopefully that kind of makes sense, because if you think about it in terms of our tables, if we know this is 1-to-1, that means none of your y values repeat. So 2, 3, 7, 9. None of those repeat for our x's, so we know that's a function. So now if we look at the y values, 4, 6, 9, 11, none of those repeat. Well, those y values are going to become my new x values. So if my y values don't repeat in the original, then they're not going to repeat when they are x values in the inverse. Let's look at it as a mapping just to see when something is 1-to-1. So here's a mapping. I've got two circles, 1, 2, 3, 4, 5, 6. So these are my x, my domain, and this is my range. So 1 goes to 4, 2 goes to 5, 3 goes to 6. It's a function because each x value is only mapped to one y value, and each y value only has one x value. So now let's look at something that's not one-to-one. So here's our x, here's our y. 1, 2, 3, 4, 5, 6. So let's say 1 goes to 4, and then maybe 2 goes to 4 as well, and then maybe 3 goes to 6. Nothing's going to 5. So here it's a function because each x value is only used once, but it's not one-to-one because this 4 has two different x values that are mapped with it. All right, number 2. Determine the inverse given an equation now of f of x equals 1/2 x minus 4. All right, step number 1. Step 1, if you were given an f of x, which you might not always be given that, replace f of x with y because it's the same thing as y, and it just makes our job a little bit easier. So y equals 1/2 x minus 4. Now, step 2. Reflect over y equals x. To find the inverse, that's all we're doing is reflecting over the line y equals x, which means we need to switch x and y. So my y now becomes an x, and my x becomes a y. So this y right here became an x, and this x became a y. And then step 3, you're just going to solve for y. So I'm going to add over my 4 and then multiply both sides by 2 to get rid of that 1/2. So instead of dividing by a half, which some of you are tempted to do, it's better to multiply by 2 because we want to try to avoid dividing by fractions. So I'll distribute my 2 in here. I get 2x plus 8, my 1/2 and my 2 cancel to get y. And then I'm going to rewrite it, and I'm going to use my inverse notation, which is f raised to the negative first of x. Now I know that can be confusing because we've talked about negative exponents mean to flip it and take the reciprocal, and that's not what this means. Inverses are not the reciprocal. This notation just means inverse, which means reflected over the line y equals x. And so I just took out this y and replaced it with f negative 1 of x, and that is my inverse. So you should be able to know if the inverse will be a function even without the equation. So is f of x equals 1/2 x minus 4 1-to-1? And looking at that, we know it's a line. So any line except for a horizontal line would pass the horizontal line test. But if I'm going to say that, I need to draw a little sketch so I know what I'm talking about, not just saying pass the horizontal line test. We've got a y-intercept of negative 4 and a slope of 1/2, so something like this. Okay, and then if you can tell me that, so if the original function is 1-to-1, is the inverse going to be a function? And you'd say yes. If the original is 1-to-1, then the inverse is a function because the original, if it's 1-to-1, that means the y values don't repeat, and those y values now become your new x values in the inverse. You also could, of course, look at this equation and know that this is a function because it's not a vertical line, but it is a line indeed. Number 3. Given f of x equals x minus 3 to the third plus 1. Letter A. Is f of x 1-to-1? And after you say that, I want you to tell me if the inverse is a function. And let's also actually add on here f negative 1 of x means inverse. That's your notation for an inverse. All right, so let's take a look at this. So you could put this, go to your y equals, and let's put this right into our calculator. So we've got x minus 3 to the third power plus 1. I'll zoom 6. It looks like that. So would this pass the horizontal line test? Yes. And I need to show that little sketch that I just did. So yes, f of x is 1-to-1 because it passes the horizontal line test, which means, therefore, the inverse is a function. Okay, that's letter A. Now I want you to find the inverse algebraically. So first thing we'll do is step 1, replace our f of x with a y. So I have y equals x minus 3 to the third plus 1. Pause the video, see if you can remember what to do next. All right, hopefully you said switch your x and your y. So x equals y minus 3 to the third plus 1. What line are we reflecting over? That's right, the line y equals x. That's how you find an inverse. And now we're just going to solve for y. So we're trying to isolate here. So first I'm going to subtract my 1. And now I want to work my way to get inside to that y. So I need to get rid of this 3 outside the parentheses. So I have two options. I can take the cube root of that, or you can think about it as raising it to the reciprocal. So the cube root is the same as the 1/3 power. And when I raise a power to a power, I power apply them, and I'd have to do it to both sides. Or probably more naturally, you guys want to take the cube root of both sides. And if we do that, we will be left with, either way, we've got the cube root of x minus 1 equals, so here these cancel out, here the cube root of the something cubed cancels out, we're left with just y minus 3. So then just add your 3 over to the other side. We can't put it under the cube root because we're not taking the cube root of that. So it'd just be the cube root of x minus 1 plus 3, and that equals y. And then lastly, I'm just going to replace it with my notation. Since they asked me to find f negative 1 of x, I've got to put it back in. So the cube root, when you're doing a cube root, make sure the little 3 goes inside the hook so it doesn't look like you're doing 3 times the square root of x minus 1. All right, let's do another one. What is the inverse of f of x equals x over x plus 3? And for this one, x does not equal negative 3, because if it did, it would make our fraction undefined. All right, so this one is a little bit tricky. But first, I'd like you guys to pause the video and do the first 2 steps on your own. So go ahead and do that. All right, so our first step is to replace f of x with y. Second step is to switch our x and our y. So now I have x equal, but I have 2 x's here, so I'm going to have 2 y's over there. So that's a little harder because I have 2 y's, and I cannot cancel these out because this y down here in the denominator is attached with a plus 3. So instead, I'm going to try to get rid of this y plus 3 out of the denominator. So anytime you have 2 of your variable, we need to try to get them together. So here, I want to get them on the same side and not one in the numerator, one in the denominator, all in the numerator. So I'm going to distribute my x here. So I'll get xy plus 3x. Here, these will cancel, giving me y. So now, and this is something that you guys looked at in algebra, I have an xy and a y. So 2 y's in this equation. So I want to get them both on the same side. and everything else on the other side. And let's just write that out. So anytime you have 2 of the variable you're trying to solve for, solving for, you want to get them on the same side. And then what you're going to do is factor it out. So everything that doesn't have that variable, you want to bring to the other side. So what I'm going to do is I'm going to subtract y over to this side. So I have xy minus y plus 3x equals 0 because I subtracted y from both sides. And now I'm going to subtract 3x over there because the 3x does not have a y in it. And I only want y's on one side and anything that doesn't have a y to the other side. So here's where now I can factor out once I have them on the same side of the equation. So I'm going to factor out my GCF of y. So I'm dividing each of these by y, which leaves me with x minus 1 equals negative 3x. Now I've gone from having 2 y's to just 1 y in my equation. Now I can solve for y by dividing by my x minus 1. So I have y equals negative 3x over x minus 1. Last step, replace it with your f negative 1 of x. So the inverse of f of x is negative 3x over x minus 1. Okay, I'm going to give you guys one really similar to that I want you to try, and you can use that last problem to help you. So find the inverse of f of x equals x over x plus 5, where x does not equal negative 5. So it just can't equal negative 5 because then there would be a 0 in the denominator. All right, so pause the video and try to do this one completely on your own, but use number 4 as a guide to help you. All right, so for this one, same idea. Put your y in first, switch your x and your y, so you should end up with x equals y over y plus 5. You're going to multiply both sides by your y plus 5. Distribute your x. You want to get all your y's on one side of the equation. And I'm kind of going a little faster and skipping some steps because you should have done this already on your own. Subtract my 5x over, and then anytime I have 2 of the same variable I'm solving for, I want to get them on the same side of the equation and then factor out. And then I can solve for y, so I get negative 5x over x minus 1, and our last step is to write it out. Negative 5x over x minus 1. Or if you had 5x over 1 minus x, that would be fine too. Same thing. All right. Number 6. Find g inverse of x if g of x equals 2x minus 8. Pause the video and find g inverse of x. All right, so you should have all the work written down here. Your answer, g inverse of x, should be x over 2 plus 4, or you could have had x plus 8 over 2. Either of those answers would be acceptable, is fine. All right, and the last one we'll do for inverses today. So the function or actually we're going to graph graph the function y equals h of x if h of x equals, actually, we don't want to write it like that. I'm going to actually just graph this for you. And oops. And I want you to copy it. So sorry, I'm erasing that so much. So the function y equals h of x is graphed below. And we're going to graph it. I want you guys to sketch a graph of y equals h inverse of x. And you can use a table if that helps you too. So first, let's draw on our axes. And your h of x is the point 1, 2, 3, 4, negative 1. Negative 1, negative 2. And negative 5, or negative 4, negative 3. And, oh, we got one more, negative 5, negative 4. So that is y equals h of x. So that is given to you, and the question is, graph the inverse of that. Okay, so what I would do then to graph the inverse is that first maybe I'd write out a table for h of x. So h of x has the points on it, negative 5, negative 4, negative 4, negative 3, negative 1, negative 2, and 4, negative 1. So now, just like our first question, you can find the inverse of h of x. So h of x means it's reflected over the line y equals x. So we're switching our x and y values. So negative 5, negative 4 becomes negative 4, negative 5. Pause the video, fill in the rest of the points, plot them on your graph. All right, so again, you should have negative 3, negative 4, negative 2, negative 1, negative 1, 4. Let's plot these. I like that. I'm going to do it in a different color. 1, 2, 3, 4. 1, 2, 3, 4, 5. 1, 2, 3. 1, 2, 3, 4. 1, 2, negative 1, and negative 1, 1, 2, 3, 4. Connect those. And you'll see here, this one is y equals h inverse of x. If I'm going to take a different color, let's take black, and graph the line y equals x. So it's at 1, 1, 2, 2. If I were to graph this line, it should go right down the middle. So if I folded my paper on the line right here, y equals x, this pink dot would go to this blue dot. You can see if you count diagonal boxes, this one's 2.5 away, this one's 2.5 away. Here, these would go on top of each other if we folded along this line y equals x. So that is your inverse. So you also could have graphed it doing that to find the inverse. So a few things you guys need to remember. Inverses are when you reflect over the line y equals x. And whenever you're finding the inverse, you switch your x and y, whether that's in a table, you switch the point, on a graph, you switch the ordered pair, or in an equation, you'd switch x and y and then solve for y. The other thing to remember is this notation here, h negative 1 of x or f negative 1 of x means the inverse. It does not mean, like, it doesn't have a negative exponent on it. It's just a notation for that. And the other thing to remember is 1-to-1. If you pass the horizontal line test, you are 1-to-1. And if the original function is 1-to-1, then the inverse must be a function. And that's it for me today. Hope to see you guys soon. Have a great day. Pie out.